Hi everybody, welcome to our hangout. This hangout is a little bit professional development and a whole lot of science, and we're really glad that you're here. My name is Rachel. I am the Director of STEM Education for WGBH, and we're here because we're starting a historic time for space science. In the coming months, we're literally going to be seeing our understanding of the solar system change daily. When I was a classroom teacher, Pluto was a topic, and at the time a planet, that my students got very excited and passionate about. And in this hangout, I'm going to be joined by Jeff and Carrie, and together we're going to be talking about this time that's going to have a whole lot in store for us, and what you, as educators or scientists or members of the public, can expect in the months ahead. And so just to say that, yes, while this hangout is for educators primarily, anybody is welcome to join, so we're really glad you're here. But it is part professional development that will address some content and pedagogy about teaching about the solar system. And it's also part casual conversation that we'd like to have with you about the solar system and why this matters. And it's also a little bit of a personal story about the work of our colleagues here, Carrie and Jeff, who've joined me. As well as some maybe stories of you, our audience members. And so I'd like to share with you that the format of these Hangouts is interactive. So please use the Q&A window, which you might notice is a part of the Hangout environment. So feel free to use the Q&A window to ask us any questions. Please go ahead and check it out and test it out now if you've never tried it before, and introduce yourself. And I will be asking those questions to our presenters here when the time is right, and we'll also have a time at the end dedicated just to Q&A. So if you don't get to ask your questions now, you can always ask them later. So I'd like to get started by hearing a little bit about our presenters and introducing them to you. So Jeff, could you please tell everybody a little bit about yourself?
Hi everybody. My name is Jeff Moore. I am a geologist. I work here at NASA Ames Research Center in Mountain View, California, which is in Silicon Valley. I am a co-investigator on the New Horizons mission, which is going to Pluto and to other objects in the Kuiper belt. And I have the job of being the head of the imaging team, the geology, geophysics imaging team. So I have the honor of help planning and supervising the planning for originally the images we are going to take, and now, of course, the analysis of those images now that we've begun taking them.
Great. And Carrie, could you tell us a little bit about yourself?
Sure. Thanks for coming, everyone. My name is Carrie Hallett, and I work at Montana State University. I'm their online science curriculum development specialist. So I've been a part of the New Horizons mission for about 10 years now. It's been such a pleasure to work on helping develop the curriculum materials. I also work on the Messenger mission, which is currently orbiting Mercury, and the Van Allen probes mission, which is orbiting Earth in the Van Allen radiation belts, creating online curriculum materials for all of them.
Great. Well, thanks, Carrie and Jeff, for joining us. So we're going to get started right away, and we're going to start a little bit with the content and sort of what this mission holds for us and why it's such a big deal and what to look forward to. And then we're going to look into some of the educational resources and the pedagogy of, how you integrate this story into your curriculum or into your communications and or your science communication efforts, and some of the sort of tools and strategies that NASA and PBS LearningMedia have to help you do that. So I'm going to ask Jeff to go ahead and get started and tell us a little bit about, before we dig right into the mission, just how big of a deal is this mission for planetary science? Are people really getting super excited about it? Is it just starting to build? Just tell us a little bit about the big picture here.
Well, certainly the team is getting very excited about it, and I think the entire scientific community, the planetary science community, is getting very excited about it. There was a big front page write-up about it in last week's New York Times science section, which I hope people had a chance to look at, or at least look at online. The reason why this mission is so exciting is that to fly close to Pluto and acquire lots of high-resolution data of Pluto will be the first time in our history as a species that we fly into what's known as the third zone of the solar system. There's the inner zone of the solar system, the inner planets, which the Earth is a member, so is Mars and Venus and Mercury. Then there's the middle zone of the solar system, which are the gas giants and their moons. And then there's this third zone, which is comprised, amongst other things, the Kuiper belt. Pluto is the largest, or amongst the very largest objects in the Kuiper belt. It's a world in its own right. The Kuiper belt itself is a place where the building blocks which made up the rest of the solar system, including, of course, the Earth, have been placed by gravitational forces over billions of years, and placed in, you can think of it as cold storage. It's like the cold storage attic of the building blocks that made up the solar system. So it's very exciting to go see these basic materials which basically comprise all of us.
Great. So what can we, expect to see, and when we get close to this? Is it going to be, I see Pluto in my mind and think about what I grew up seeing, which was either artists' renderings or gray, fuzzy, modeled patches once, Hubble got involved. So what's going to get involved now? I'm sorry, go ahead.
Well, I was going to say there's a number of instruments on the spacecraft, including ones that determine composition and so on. But since I'm the leader of the imaging team, I'll talk about what the pictures will show. And I just saw you had a picture up a moment ago of Manhattan, or of Greater New York. And that picture gives an example of some of the quality of the resolution of images that we will be acquiring during the encounter. We will acquire pictures that have resolutions of around 70 to 90 meters per pixel, and so the full scale resolution of this picture of the New York area, I'm not sure it's coming through the JPEG artifacts that come from streaming, but in the original version of the picture we used, you can very clearly see the ponds in Central Park, and you can see the docks down by the Battery. You can see the major north-south road systems such as Broadway and so on, and so we will be able to see things of that size, that quality, with the New Horizons imaging system during closest approach.
So can you give us an idea of the kinds of new what you expect it to look like? Is there an analogous moon or planet or something, or do you think this is going to look entirely different, or do they really just not know? How much do they think they know what they're going to see when the images are coming in?
We can see Pluto, although as a very tiny disk, through Hubble and other telescopes such as it. And we know from these Earth-based observations that Pluto has amongst the brightest and darkest surfaces in the solar system. So there are places on Pluto which we already know that are as dark as charcoal and as bright as new fallen snow. We also know that the surface has a lot of color extremes on it. So, for instance, there are regions which are amongst the reddest in the solar system. So we have reason to believe that the surface is, well, we know for a fact it's variegated. It has these ranges in color and brightness. And from that, we anticipate that it will be a very exciting surface, but I think it's risky to speculate much beyond that of what the surface in detail will look like before we get there. If we knew what it would look like, there'd be no point in going, right?
Right. That's a really good point. So is there anything that, what are some of the key advances? For people here who have been following this mission, or obviously who've been following the solar system and love space for most of their life, or are educators, what are some of the key sort of findings or advances that you're looking forward to this mission giving us? Well,
because we have a very good imaging campaign, so I'll speak to the images first, we will, for instance, produce a high-quality topographic map. We'll know what's up and what's down, and how high up and how far down it is, and what sort of slopes the surfaces of ridges and the pits and so on will have, to a quality that's comparable with typical topographic maps you see of a state, for instance. So we'll have a good idea of the topography of Pluto, which in geology is absolutely essential in being able to finally differentiate between one type of geological process and another, which might shape a surface. Like, for instance, you might see a picture of things which look like wiggly lines or wiggly ridges in an image, but if you can't tell what's up and what's down, you don't know if you're looking at sand dunes or features formed by mountain building forces or what. But with topographic information, we will have a very good idea what has operated to shape the surface of Pluto. And we will have, as I say, this great coverage for the entire near-encounter hemisphere. We're going to produce a global, or I should say a near-encounter hemisphere data set that is of a resolution that's better than the best images ever taken, for instance, by Voyager 2 when it flew past Triton in 1989, which some people think may have some features similar to that of Pluto, but of course we'll only know that after this July, after we've flown past the Pluto system. And also the Pluto system has, one other very large object. Its moon Charon is almost half the size of Pluto itself, and it looks different even from the distance of the Earth. It doesn't seem to have a lot of albedo contrast, or I'm sorry, brightness and darkness contrast on it. And it appears a lot less colorful, so they probably have very different surfaces. So it's at least the two for the price of one, but like those late night ads you see. But wait, there's more. Since the beginning of the 21st century, we discovered 4 much smaller moons. With the expectation, we'll probably find maybe a few more little moons. These moons are much smaller. They're probably not more than 50 miles across, and they orbit much further away from Pluto than Charon orbits around Pluto. But Pluto is not just a planet out there; it's a planetary system with 5 known moons. So it's going to be exciting. We're going to look at all of them. We're looking forward to reporting back to everybody this fall when we can show you the results from our encounter.
That's great. Well, that leads us to another good question, and I'm going to bring up your next slide here and ask, can you walk us through what's ahead? This is a story. This is going to be an ongoing, emerging mission with new images coming out. What, daily or hour? I mean, how many new images are you going to get a day? At peak data.
Well, that's a little. It's a semi-tricky question because, well, for instance, during the closest approach, we're going to take hundreds of images. But because we wanted to make this mission as economical as possible, we put a relatively small radio antenna on the spacecraft. So in order to get all those pictures back, we first dumped them onto a solid-state memory on board the spacecraft. And then over weeks and months, we will relay the pictures back to the Earth. So while we will certainly have some spectacular pictures, a handful of spectacular pictures to show people in July, the bulk of the data is coming down in the fall and early part of 2016. Although we anticipate having some stuff that will really blow people's socks off right away and in the first few months after the encounter. So basically, we're just telling people to stay tuned. So that, I know that's kind of a funny and convoluted answer, but the answer is we'll be taking lots of pictures close to the target, but they're coming back to the ground at the rate of a few a day. And
so about a few a day.
And then go back to your earlier question about taking pictures now. Well, we've just begun our imaging campaign, and the cadence early in the encounter is relatively slow. And I understand that there'll be an image released to the public on average of probably like once a week over the next few months. But things will really begin to build up in May and June as we begin to get closer and closer to the target.
And releasing images is a little bit different than starting to talk about sort of what the images are doing to our understanding and the sort of the findings. So, when does some of the, granted you never know, like you say here, the most exciting discoveries we can't anticipate. So we don't know when some of the findings might really start to be released about what you're learning from these images. But
well, we're going to have, I'm sorry.
No, go ahead.
We're going to have, some images down in the week of the encounter, and there'll be press conferences, and you'll see our team stand up and report out the things that we see in those first few images. And then we plan to have a much bigger presentation, mostly to the scientific community, in the fall. I think the first big scientific presentation is going to be in Washington, D.C. in mid-November of this year. But as we continue to see things and report on them, there will be regular releases to the public. And moreover, there's going to be a raw feed, that is, the images come down from the spacecraft. We're just going to post them without comment as well, like most missions do these days. So people can look at the images and speculate for themselves what they're looking at.
Great. Well, we have some questions rolling in, and I do encourage anyone else viewing. We have a lot of viewers, and welcome. If you don't already know, this is interactive. There is a Q&A window or box that you can please type questions into. We have one I'm going to ask you, Jeff, from someone who asked, what is the danger for New Horizons, if there is any, as it flies past Pluto with the newly discovered moons?
Well, I tell people that the thing I fear most about the encounter is that we'll have so much data on hand that I won't have time to analyze it all. But in fact, when we saw all these new moons, when we saw all these new moons, we did prudently investigate whether these moons might possibly generate debris, which could be a hazard to the spacecraft. And after a very careful study, the very best model suggests that they're essentially a negligible threat to the spacecraft if we stick to our nominal flyby trajectory and sequence plan. But even though the models suggest that the risk is very small, less than 1%, we nevertheless are still prudently taking images, long exposure images, as we fly in towards Pluto to see if there aren't yet things there which we need to worry about. And we already have planned several contingency trajectories and encounter sequences that we could employ if we saw something wholly unexpected that would force us to take a different path past Pluto. As I say, the likelihood of that is extremely small. The model suggests it's well less than like 0.1% or some number of that nature, a very small number. But nevertheless, just because the whole space exploration game, as everybody knows, requires that you have contingency plans and you've been prudent and you've done due diligence to make sure you've covered every possible thing you can imagine, we have thought of all those things, and we are as prepared as one can be to deal even with the wholly unlikely events which might happen.
But like you said, it's always the unknown that you can. And
again, the issue is that if you knew everything about the place, you wouldn't go there.
So the story of the evolution of the moons of Pluto, I think, is another one that's great. Like you said, there's 5 now, and 2 of them came about right before the launch of this, and more came after the fact. I mean, for those in our audience who might not know that, can you say something just briefly about, now you're talking about 5 moons, and could you find more?
We could find more. Every time we find a new moon, it's dimmer than the moons we've already found. And if there is a 1-to-1 relationship between brightness and size, it means we have found the next 4 largest moons, all of which, as I say, are small. They're not probably more than 50 miles across, probably smaller. And if we see 1 or 2 more moons or a few more moons on the way in, then they will probably then be even smaller. They could be only a few miles across. And as I said, all these new moons, they all orbit much further away from Pluto than Pluto's big moon, Charon. And we think Charon basically acts as a bodyguard and sort of takes the bullet for Pluto. So we think that Charon will have swept up any of the debris which may have come off these little moons, which might pose a threat to the spacecraft. So as I said before, after the very careful modeling, we think the path we are taking through the Pluto system is amongst the safest one can evaluate.
Great. Well, we have a couple questions coming in about the instrumentation and the cameras. I'm going to ask 2 of them, and then I would 2 particular ones, and then I'd like you, Jeff, as an imaging lead, I think this is right up your alley to talk about some of this instrumentation. One question asks if you can tell us a little bit about, and again, this is, I know, an acronym, but LORRI, which is LORRI. Is that how you pronounce it?
Yeah, LORRI. We call it LORRI. It
Right.
stands for Long Range Reconnaissance Imager.
Okay.
And it's basically our telephoto camera. It takes only black and white images, but it does have a telephoto lens. And it, for instance, it permits us to do several things, not the least of which we will be able to image the hemisphere, which will be turned away from us during the encounter. Obviously, you know, you can only see one side of a planet when you fly past it. So the hemisphere that's blocked by the hemisphere you can see in the foreground, we will be able to see it with resolutions of around 10 miles per pixel. And that would not have been possible had we not flown the telephoto camera. Plus, the telephoto camera will be the camera that takes pictures of things that can see objects as small as the ponds in Central Park. So the telephoto camera, the LORRI camera, is the camera that will take the close-up pictures when we're nearest and take the context pictures of the hemisphere we can't see when we're still far away.
Great. So there's some other instruments that I know are mentioned here. Alice, Rex. I was wondering if you could share a tiny bit more about some of these other instruments and what their capacity is and what they're going to, you know, tell us about Pluto.
Sure. The ALICE instrument is an ultraviolet spectrometer, and it will be able to tell us a lot about the atmosphere of Pluto. Pluto has a thin atmosphere. You don't know how thin it is. It could be thick enough that it may form small ripples and dunes on the surface, which we will look for, of course, with the cameras, but we will also compare that against the actual thickness of the atmosphere and the winds of the atmosphere, which are things which we can learn directly or indirectly about from the ultraviolet spectrometer, the ALICE instrument. And the REX instrument is our radio experiment. We use this antenna that I mentioned before that's relatively small. We did that for mass savings and thus cost-saving reasons. We'll also operate in an interesting mode where the giant antennas on the Earth will broadcast powerful radio signals towards Pluto, and we will listen with our antenna on the spacecraft as we fly behind Pluto and then fly behind Charon, and how the signals from the mega radios on the Earth are attenuated as our spacecraft passes behind Pluto and Charon will also be used to construct the profile of the atmosphere, to understand how thick the atmosphere is and how it's you know, what its layers are and things of that nature. And then there's an instrument called the LISA instrument, which is our infrared spectrometer, and it will tell us about all the different kinds of ices which cover the surface of Pluto. Since we know Pluto has all these variations in color and brightness, we are sure that those variations in color and brightness correlate with different types of icy compounds on the surface. And we can see that those icy compounds, at least some of them, are already there from Earth-based observations of the composition of Pluto.
Great. So, and I think that sort of covers it for the instrumentation questions that we've had. But I know that this was launched, you know, about approximately a decade ago, or I think nine years ago, and the question
January of 2006, so it's launched almost exactly 9 years ago.
Okay, great. I remember the launch event very well. So the question of, I mean, at the time, I'm sure this was the best, you know, imaging technology we had, and how does it compare to today with the fact that, you know, our instruments are I mean, we have cell phones that have cameras in them that are incredibly high resolution in that. But can you give us sort of a, you know, does this still rank up there in terms of a really super high quality image that we're going to be getting, or?
Yes, the imaging systems on New Horizons are amongst the best imaging systems that have ever been flown on any spacecraft, and they compare favorably with modern imaging systems. There used to be a time when we would launch spacecraft that would take 20 years to get to their target, and by the time the spacecraft arrived at its target, the imaging system that would be used would be superseded by modern equipment. But we don't really have that problem. If you could somehow wave the magic wand and put some, you know, state-of-the-art 2015 camera on the spacecraft, you wouldn't probably put a camera on very different, or cameras very different than the ones we have on it now.
Okay, great. Well, that's good to know. So we have a couple questions about sort of the mission itself again. So I'm going to go back to a little bit about the sort of flow of this mission, if you don't mind. One question,
Okay.
are we going into orbit, or is this just a flyby?
No, it's just a flyby, and it has to be that way because Pluto is very far away. And if we were to have any chance of having a spacecraft arrive within the lifetime of anybody alive today, we would have to be going, and we are going so fast that you couldn't take enough fuel with you then to slow the spacecraft down and go into orbit around Pluto. So
Right.
you can't quite have your cake and eat it. You can either get there in a reasonable time period, a decade, and see the place, but keep on going about your merry way, which, by the way, works to our advantage because we're then going to go on and visit some other objects in the Kuiper belt, or at least one more object in the Kuiper belt besides Pluto. So if we'd gone into orbit around the Pluto system, we wouldn't then have the ability to go see at least one more Kuiper belt target.
And actually, that is a question I'm going to ask next, or I should say after this next one. Regarding the flyby itself, approximately how long is this closest encounter going to last, given how fast New Horizons is traveling?
Well, that's always a funny question because the short answer is that the moment of closest approach is an instant, right? There's only
Right.
1 minute you're closest to anything. But in reality, we'll be seeing lots of geological detail for a couple of days before the encounter and for about a day afterwards at the scale of things that planetary geologists use to map landforms and recognize landscapes and identify the processes which operate on them.
Great. Well, thank you. And then this next question speaks a little bit more to these Kuiper belt objects. So as far as after the closest approach happens, have any Kuiper belt objects particularly been selected for New Horizons to visit, or is it more open-ended? And how do you have sort of an open-ended mission?
Well, first of all, you have to, because Pluto is relatively small, relative to, say, Jupiter, for instance, you can't really use Jupiter's gravity to bend the trajectory to go to a new target. So you have to actually carry the fuel with you or the propellant with you to change your course and fly towards a new target. So there was basically you can think of it as a cone that extends beyond Pluto, in which objects which we would fly to after the Pluto encounter would have to be inside that cone. And just this summer, with the help of the Hubble telescope, we discovered 2 such objects. And we have not decided which of the 2 objects we will fly to. We know we don't have enough fuel to fly to both of them, but we will burn a trajectory. We'll change the trajectory towards one of them, and then we'll have to seek funding from NASA to actually collect data when we fly past the Kuiper belt target beyond Pluto, and that's just a governmental process which still needs to take place. But we'll have to make the decision soon after the flyby to spend the fuel to put ourselves close to the new target this fall.
Great. Well, if anybody has any more questions, we can take more at the end. There's going to be a Q&A session at the end, so please don't think this is the last chance you have to talk to Jeff. I will say the reason that you aren't seeing Jeff is that, ironically, being the image lead, he doesn't have a camera for for us to see him. So, but we really appreciate some of the great images he shared with us.
I have my cameras pointed at Pluto.
I know all his cameras are pointing at the really important stuff, right? As he said.
Exactly.
So, Jeff, when was the first time have you ever looked through a telescope at Pluto? And if so, as a person, when you were doing, I know you talked about looking at things when you were younger through telescopes. What got you into this? And did you ever think when you were young you'd be sort of the imaging lead for some of these leading missions at the far reaches of our solar system? That's amazing.
I think I answered the first question a little easier. Well, I was born in the early 1950s and grew up in the 1960s during the height of the the original space age, the moon race, and all these things. And so there was a big push in the United States to, quote, catch up with the Russians. So public education systems were substantially beefed up in the late 50s and early 60s. I grew up in rural Oklahoma, and our money was available and resources were made available to make sure that America maintained a intellectual prowess to successfully compete with the Russians, which of course we did. And as I say, space exploration was it's one of the waves of the future. And Oklahoma has clear, starry nights when it doesn't otherwise have tornadoes. And my parents, got me a nice little telescope, not just a little cheap department store one, but a good little telescope. And I started looking at the planets, and it got really. And I've also been always interested in geology. I'm a geologist. People ask me what I do for a living. I tell them I'm a geologist. And so it was a natural merging of interest in geology and the opportunity to think about how the geology of other worlds might be, and I became very interested in as we began to see the surfaces of other planets in the 1960s, like the Moon and Mars first, and then Mercury and so on. I became very, very interested in it and went to college and pursued degrees and became a planetary geologist. The second question, my telescope that my parents got me in the 1960s wasn't powerful enough to see Pluto, but by the 1970s and 80s, I could hang out with people that had bigger telescopes, and I have seen Pluto through a telescope, and it was a very tiny, faint dot in the telescope.
Wow. So what a difference it's going to make.
Absolutely.
I'm excited too, and I know many of the people who are writing in our Q&A box are saying. In fact, one person in the audience was actually at the launch of New Horizons and has the mission patch. So we have some real big fans here. But we have a couple other questions that that have come in that I'd like to just see if you could help people answer. One is, how fast is really New Horizons, the satellite, traveling right now, and is it going to be varying through this mission, or is it really just got a nice steady pace?
Well, basically it has a steady pace, and that steady pace is about 10 miles a second.
Wow, 10 miles a second. Okay, so that answers that question. That's almost hard to fathom. Like that would get you. Yeah, I'm trying to even think of a.
Well, to give you a sense of how fast the spacecraft was when it left the Earth, that it was the fastest object ever to leave the orbit of the Earth, man-made object to leave the orbit of the Earth. After the orbital insertion burn took place, so the burn put it on its trajectory to Pluto, the spacecraft crossed the orbit of the Moon in 9 hours.
9 hours.
In contrast to the Apollo spacecraft, took 3 days to get there.
Wow. Okay, I think that right there gives you a great scale, a great sense of scale. So as New Horizons continues to approach Pluto, what phase will it be in the planet? Are we going to see it's a full Pluto because we're coming right at it? Is there any sort of a phased we're going to see?
Well, we actually picked a distance to fly by Pluto, and then we built the cameras to match that distance. So we'll see Pluto, as we approach Pluto, it'll look like almost a full phase, almost like a full moon, if you want to think of it that way. But as we fly past Pluto, it will go from a nearly full phase to a half phase to a crescent. And we'll be taking images throughout the entire series of those phases. And in fact, I know you have some of my slides up. I think if you go to the next slide and then the slide after that, you can see Pluto showing its various phases. There we go. And for instance, in this image, you'll notice in this slide on the right-hand side, you can see that's pretty much what Pluto will look like during closest approach. And those little red boxes are the size of our lorry frames on the surface, and the big blue box is the size of our wide-angle color camera on the surface. Just to give you a sense of the kinds of coverage we're going to get during the encounter.
Great. That's really helpful. So I'm trying to see if there's any other. We have a lot of questions that have been rolling in, and I was just seeing if there was anything left that we could address in the short term. But I think that one other one that I think is a particularly interesting one here is someone who really loves the mythology, especially of Charon and the folklore. And the question is there a naming scheme for Charon? Like, do you name certain craters? Or when we start to see, I guess I never thought of that, but when we start to get a much higher resolution image of these moons and bodies, we're going to start seeing craters and features. So how are we going to be naming them?
Well, the science team is working with the International Astronomical Union, and a list is being proposed for the mythologies and nomenclature, the names of things. We don't know what things will be there yet, but we're working on it. It's a work in progress, so I can't tell you more than that. But indeed, we have thought about it, and lists of potential names are being compiled, and approval of those names is being sought to name features on Pluto, Charon, and the other moons.
Great. Well, that's great to know. So there is a naming scheme that is in development, and
Yes.
we're going to have features and craters and things that we're going to need to be named, and that's a cool angle I hadn't thought of. So thanks for asking that.
Yeah, and I think there's going to be a public campaign where people can go to a website and propose names. I can't remember the exact deadlines or the time frame which it's going to take place, but if my memory serves me, I think it may be in March. But I suggest everybody go to the New Horizons website at the Applied Physics Laboratory, and that information, as it becomes known, will be posted there.
Great. Well, so one question about looking up close at some of the features that just came in is, do you think that will New Horizons be able to determine whether Pluto and Charon have any subsurface oceans? And I'd like to start by saying, is that even possible at this distance? And with this sort of lack of strong gravitational pulls, or though maybe, I don't know, I'm going to let you take that.
Well, the reason why one might at least entertain that idea is that while Pluto and Charon are very far away from the sun, they're also made of very volatile materials. They're made out of nitrogen and methane, and nitrogen and methane, of course, are gases on the Earth, and only because Pluto's so far from the sun do they condense out and form basically a frozen, hard, rocky surface. But one could imagine going into the interior of Pluto, where it's not inconceivable that there could be at least a thin layer of liquid of one of these or both of these principal components of the crust, which are nitrogen and methane, probably in addition to a substantial amount of water ice. But water would be so cold that it's virtually inconceivable there would be any kind of liquid H2O anywhere inside Pluto or elsewhere. But it's certainly not inconceivable that there could be liquid layers of methane or nitrogen, perhaps. But again, we'll just have to see. And the images might only be able to indirectly say that that's the case. Like, for instance, if we fly past Pluto, and Pluto, for instance, had smooth plains on it, like the dark patches on the Earth's moon, which is, the dark patches on the Earth's moon are formed by lava flows. So if we see smooth patches on Pluto, we might think those are formed by the extremely low temperature equivalent of volcanism, which is, as goes by the buzzword of cryovolcanism. And so these cryovolcanic flows, if we see them on the surface of Pluto or Charon, would let us know that there had to be a time when there was liquid in the interior which erupted on the surface.
Great. Well, thank you. So we have a couple other science questions that are sort of broader that, if you don't mind, Jeff, I'm going to sort of leave those to the end when we have our just open Q&A.
Okay.
And I'd like to give some special time here to talk about sort of, given this mission and what we have as educators we're facing as an opportunity here to tell this story and bring it into our classrooms and inspire. I know that when I taught astronomy, the majority of my students were incredibly passionate about the subject of Pluto and the understanding of sort of the what we don't know about our solar system. So Carrie, who's joining us as an educator, who wrote and authored, I think, many or all of the New Horizons educational activities, I'd like to sort of start and invite, first of all, Carrie, I'm going to invite, if there are other educators out there who have ideas about how they bring this story into their classroom, and it could be you teach physics, you teach astronomy, you teach earth science, please put them in the Q&A box, and I'd like to share some of those, because the question I have for you, Carrie, is it might not be in the curriculum, but kids care about it. So how do you bring this story in and use it as a really great teachable moment in your classroom, and then take that to the next level and get it transferred into some more, information the kids need or have to learn anyway?
Yeah, well, it's great, and as you said, we all who grew up with the classic 9 planets care deeply about Pluto. And I think that has really passed on to generations that didn't even grow up with that, but now know the story. And Jeff said maybe it's the underdog sort of situation where people just feel like Pluto's an underdog, and so they care deeply about it. And there's this love and this passion. So I think we're already starting at an advantage where we can capitalize on that. Love of Pluto and bring it into the classroom that way, and we're starting out where students are already excited, which is great in any of the science topics if we can capitalize on that. But I think the other really important sort of message here is that this is current science, and I think I'm going to paraphrase. I think it was Alan Stern, the PI for the mission, that said something along the lines of, what we're going to learn over this next year and plus, and more with all the data that's going to be coming back, is we're not going to be rewriting the textbook on Pluto. We're actually drafting the first edition of the textbook on Pluto. So this is very current science, and that's important for students to know about. And it inspires so many of them, like Jeff, and like a lot of the other astronomers or planetary scientists or engineers out there. This inspires them to become that planetary scientist or engineer, is just being at the forefront of science, which is amazing. So we have to capitalize on that. Oh, go ahead.
No, I was going to say, I know that you have put together, and there soon will be a new educational site for New Horizons for educators who are interested in looking for particular curricular materials to bring this, like you said, this story of this mission into their curriculum and instruction. Can you share some of those with us?
Sure. So I have 2 things that I wanted to share with you. One is a document that Rachel will tell you it's in the folder or something, language there. So that document I created specifically for those of you here today, and I picked out special activities that I thought could highlight different questions or concepts that you and your students will be seeing in the media, or possibly questions that students will come into the classroom with. So I'll go over those very briefly, but those are in that document. And then at the very end, all of those are also available on the website through links that I provided on the New Horizons website under the education area. But there are a few at the very bottom that are some 3D resources that are not on the website. So those are only in that Word document. And I think we'll be adding them to this revised website that we're going to release soon. I'm going to share this with you. Did that come up okay,
yeah.
Rachel?
Yep, there's the new website right there. And this is
those documents or those links are all available on the website except for the 3D printing ones. And so this is the new, it's not a new website, it's a revised website of our current version. And so I just wanted to point it out to you because you'll have to, it won't be this URL that you may see here, but you'll be able to access from the main New Horizons website, click on Participate, and then Teach. And we've changed the format a bit. I think it's more teacher-friendly, so it's laid out by grade level. So this is a K through 2 activity here. These are 3 through 5, 6 through 8, etc. So I think this is going to be really great, and I'm sure we'll be adding those 3D resources to this also. So what I wanted to, so I'm going to stop sharing that, I think.
Great. So we
and yeah. So I wanted to mention, Jeff talked about how we're flying past Pluto, a flyby. And this is actually part of the natural progression of studying a planet. And there's a really cool activity that helps you bring that message. So if a student says, why are we just flying past? I want to go into orbit. Yes, we're going way too fast, and that's a big part of it, is the technology to get to such a faraway place and not go super fast. But it's actually a cool activity where they can sort of explore this concept by looking through a toilet paper tube from across the room, which would replicate how we first have seen Pluto through telescopes, Earth-based and Hubble telescope. And I know one of the questions was, you know, how long is the closest approach, which of course is just a moment. It will actually be exceeding the resolution of Hubble Space Telescope. So really, I think the closest approach begins at the end of May when we're getting a better resolution than we've ever had before, which is pretty amazing. But so that is called Strange New Planet, that activity that looks at the progression from telescope-based observations to a flyby, to an orbiter, and then a lander, and the data that you can glean or what you can learn about a planet from each of those vantage points, and each have sort of pros and cons. Obviously, we'd all love to land on Pluto, and hopefully we're alive someday to see that. But anyway, so that's one of the activities provided that I think will help address a common question that you'll get. And then another one would be,
Can I ask you about the debate one? Because I think the one that, I mean, I remember I was teaching in a classroom when Pluto was sort of demoted to the dwarf planet status. And I know that it was a really useful experience to have the debate with the students and make them support their arguments, because some of them got, like I said, very passionate, but they didn't really know why. And if you have to really dig into the reasons behind it, it forces you to then really get into some of the, you know, the more the detailed information that you might want them to be learning anyway. So, do you have? I mean, do you advocate for having the debate with your students, or, and if so, how? I mean, what are some of the do you have a lesson plan and then around a debate?
Yes, actually, we do advocate it. And by the way, Pluto wasn't demoted; it was promoted to the king of the ice dwarfs.
So as Neil Tyson said, yes.
Yeah, right.
I worked at the Hayden Planetarium at the time it became, and I worked with Neil when the new exhibit came out in the Rose Center, which didn't have Pluto in it, and sort of sparked the whole conversation around Pluto being a planet. And I remember, you know, we got the second graders sent hate mail. You killed Pluto. So they get very passionate about it, which is a great thing to see. Students get that excited and interested in something.
Right, and to capitalize on that, like you said, I mean, that they're already interested in this. This is an interesting story. So we do have an activity. It's called What is a Planet? And it looks at classification of objects, generally speaking, and it looks at the classification scheme that we have. And they are then armed with that knowledge of how we classify things, and they have undertake a formal debate on a fictitious planet that was supposedly discovered by New Horizons. And they have to take a side and argue that side of whether she should not be a planet based on the current definition. And I think one of the messages that should come out of this too, and that you can really bring into your classroom, is so the definition for a planet has changed in the past few years. Is this the final definition for the word planet? Have we really come to that final definition? Or maybe something that New Horizons discovers might shed new light on that definition. It may change again. So science has to incorporate new information, and we have to evolve with it, and this may not be the end of this story.
Great. Well, so I have a couple teachers who have joined with me. It'd be nice to share some of those. Catherine says that she uses this mission as an example of how our model of the solar system is constantly being updated, which is very much what you just said. Sort of, we have a model, it is always being updated in light of new data and new information coming in. And
Right.
so that sort of evolution and increasing detail that you can add to a model and what you can learn from a model. So it's a great, not only the practice of science in action, but how models continually get refined in the face of new information. So thank you for sharing that. We have another educator who shared some various ideas for different types of subjects in that. So for Earth science, comparing the atmospheres and surfaces as compared to the Earth, which Jeff was great because that's what you did with, first of all, showing us what Manhattan is going, you know, comparative what you'd see from Manhattan as compared to the Pluto. So scientists do the same thing. That's a great educational strategy. Physics, studying orbits. That probably opens up the debate about what a planet is, because I know orbital dynamics is important there. And the history of planets and discovery, and in art. I think that's another thing that we probably should address more, but that there's art there's art angles here too about what they look like from different distances and how you might represent them. So are some of those, those probably connect very strongly, Carrie, to some of the activities and resources that you have on the New Horizons website.
Yes, and hopefully we'll be adding more along those lines. Like, for example, I know of a cool art activity. It's called Art in the Cosmic Connection, and it looks at the intersection between science and art, because really scientists are interpreting data in the form of images quite often, and we as humans, as part of the human experience, are interpreting images and art around us all the time. So it's a cool activity, and I'm excited to add some. We don't have any Pluto images in our Art in the Cosmic Connection collection yet, so I'm excited to add Pluto images to that activity, and then we'll add that to the website. And I wanted to mention, you said physics, and two things came to mind. One of them is that one of the reasons, or one of the ways that New Horizons was able to get to Pluto so quickly was due to a gravity assist maneuver from Jupiter a year after it was launched. So the spacecraft flew past Jupiter fairly closely and used that gravity encounter to actually speed up its trajectory and change it a little bit. And we have a cool activity about that that uses a gravity assist simulator, so you can see a spacecraft traveling close to a planet, or actually 3 different distances, and see how it changes the speed of the spacecraft as a result of that encounter. And also, other spacecraft use gravity assist maneuvers to slow them down to get into orbit. So it's a really cool activity for a physics type setting, and so many missions use gravity assist maneuvers to get to where they want to go, so it's really ubiquitous in the actual world out there of space science. And the other one was, and Jeff may want to add to this, but one of the techniques that that New Horizons is going to use to learn more about Pluto's atmosphere, and Sharon's, I believe, is to look back toward our sun after it has passed the planet. So it will turn around and look back and be able to use almost like use our sun as a stellar occultation device. Usually we're using other suns for that tool. But we have an activity, I think it's a 6th through 8th grade level activity, but it might even be younger, I can't remember exactly, but called stellar occultation, or no, it's called, sorry, blanking, stellar illumination. But that helps students learn about that technique because I think they may be hearing about it on the news, and that might be an interesting concept of how we're really maximizing our data there and using our sun to learn about the atmosphere of Pluto is sort of interesting, I think.
That's great. And so just so you know, the resources that Carrie has talked about, including the NASA Wavelength site, which is a great source of a wealth of these, in fact, almost all of these resources are available there, is available to you in the showcase. There's a showcase that goes along with this Hangout that has these links directly to these resources in them, and it will also be included in the YouTube channel, the YouTube video. In the More section, there'll be a link to where you can find all of these resources in one place. So I hope that will help you find these. We also have a great resource that I'd like to share with you that has sort of more of a narrative approach to dealing with the stories from the public media side that we've put together at PBS LearningMedia. So I wanted to share these with you to accompany some of the resources that Carrie shared with you. So I am on the PBS Learning site, and I am on a special collection that is called the NASA Planetary Science Collection. And this collection of resources addresses the solar system, the inner-outer planets, the dwarf planets, and small bodies, and also a special section for professional development to help any educators take a deep dive into the content and background information should you be teaching these subjects. So I wanted to go directly into the dwarf planet collection and to highlight what some of these resources that might accompany this mission, including the Pluto dwarf planet story, and another one here called The Changing Views of Pluto, which I think is very relevant to what we're talking about today, which is how this mission is going to cause dramatic changes to our understanding of the surface of Pluto and how computer processing and imaging is going to be changing that, that story and understanding. When you go into one or any of these resources, this is the one particular one about the changing views of Pluto, you can watch the video. I'm not going to go right into it because I'm speaking over it, but you can watch the videos in their entirety. You can download them. We know many educators need to download them because they don't stream well in their either their classroom's Wi-Fi or internet. And then there's supporting materials. I will also say this is available in Spanish for any educators who have English language learners or would need Spanish resources. The support materials, when you go into them, you will see there are teaching tips that help you with beginning a lesson and integrating it and into a larger sort of lesson plan. A background essay about the content to help you with understanding a little bit more about the specific scientific content you'll find in the video clip, and discussion questions you can use with your student. These are also all aligned with educational standards, National Science Education Standards. So there is, like I said, a whole collection of these that you might find useful individually or as a whole. And then there's the professional development resources. And we're particularly proud about these because we've authored a couple of professional development sort of experiences for you. One of them is about the solar system and teaching the as a system, the big picture view. And another one is about the surface geology and what the some of the surface imaging, and this is probably particularly relevant to the mission that we're looking at with New Horizons because so much of what we're going to learn from it is about surface features and what we can learn from surface features. So when you enter one of these, it goes right into a sort of self-paced exploration with the big ideas, and it knits together particular video clips with student, or you can use this with your students, but we wrote it particularly for educators. However, we do find teachers who find this very useful as an interactive tool to use directly with their kids. So I just wanted to share these with you as well. And between what Carrie had to share and what we had at PBS LearningMedia, you should find some great things to get you started with teaching about this topic and bringing this mission into your classroom. I want to see if there's any other ideas from any of our other teachers who are joining us and that I can share. Let's see.
While you're reading those, Rachel, I forgot to mention that Jeff had talked about how long it takes in general terms to get the data back, and that it's going to take a while. I think it's 4.5 hours each way to send a signal to and from New Horizons. So we have several activities about the signal-to-noise ratio. They're in that section. And I think data will be coming down for 16 months after the encounter because of that slow rate and the small antenna that Jeff talked about. So some activities that students might be interested in that.
That's wonderful to share. I hadn't thought of that. I have one other idea here that I thought was particularly great. Catherine, an educator, shared that her students, and she and her students have a pool of how many more moons are going to be discovered with this mission. So, Jeff, any ideas? Should Catherine get the inside scoop for you and be betting on something that
Well, I think we'll all find out at the same time, pretty much. As I said, the images are going to be posted on the APL website, and I'm sure the public, like again, I think of groups like unmannedspaceflight.com, which the Planetary Society sponsors. We'll probably be doing the same thing we are, which is taking the pictures and blinking back and forth between them to see if we see any new objects. At the same time, I'm sure we'll announce new moons as we discover them. Now, how many we'll discover, who knows? You know, it could be, I'm not going to even speculate. I would only say it would be a little surprising. I always say it would be a little surprising if we don't see any more new moons.
Okay, so greater than 1, or greater than 0.
Greater than 0 or less than 1 would be a surprising result to me.
Okay, great. Well, Catherine, thanks for sharing that, and I hope you win, or at least it's good to know that you've got your kids engaged in that. And so I wanted to just say that, Jeff, we hope this is not going to be the last time we'll get a chance to talk with you, and we'd like to have the opportunity to check in with you later on in the mission once the images start coming in. So everybody who's joined us tonight, this is not the last, hopefully, Pluto New Horizons hangout that we're going to be doing for educational audiences. So look for that and follow our PBS LearningMedia and WGBH education feeds. We have a link in the showcase and below the hangout window or event page that will help you find us and connect to us. But we have a couple of final questions, if you don't mind me asking here, Jeff, and I think some of them are for you.
Okay.
One of them is, it says, as New Horizons travels into interstellar space, are there going to be instruments aboard that will continue to send back data as it travels? And is it ever going to pass or catch up with Voyager? I mean, sort of what's the end game for this mission?
Well, the instruments will continue to transmit, and we'll probably be able to continue to get signals from the spacecraft, probably way into the 2020s or early 2030s. I mean, we don't know of any other object we're going to fly near after we go past this Kuiper belt target we've identified, and we'll probably fly past it in early 2019. So I'm not sure how useful the cameras or the spectrometer are going to really be, except of course if we can still use the cameras, especially the telephoto camera, to look at even Kuiper belt objects which are very far away from us and see them at viewing geometries you simply can't take advantage of from the Earth. So there will continue to be some science of these distant, very distant other objects that will be in the general neighborhood that we will also look at. And whether catch up with the Voyager spacecraft, well, that's it depends on how you define that. The bottom line is that they're all going in extremely different directions, so there's never going to be such a situation where one passes the other. And plus, the Voyager spacecraft, especially Voyager 2, had 4 gravity assist flybys, not just one. So Voyager 2 is traveling very fast, and it will always probably be further from the sun than New Horizons will be, because it also has a 30-year head start on us.
You got quite a head start, too.
Yeah.
Probably. Okay. So are there any scientific debates that, speaking of debates, that you think will be settled after this mission?
Well, I think there'll probably be many scientific debates settled after the mission, but again, we need to see. It's almost like a Douglas Adams question. The answer may be 42, but what was the question? So I think we're going to have to wait and see what are the things we see when we get to the Pluto system, and the things that are revealed by the encounter will obviously fuel and perhaps even settle several questions people have had over the years about what's going on in the outer solar system. But again, I think we are on the verge of discovery. We should simply freely acknowledge our current level of ignorance and say that it's premature to speculate about what even questions will be settled by the encounter at this point.
I think we lost you, Jeff. I hope not.
Can you hear me now? Are you there?
We lost you. Yes, we lost you for a moment, but you're back.
Okay, I was simply saying that I think we know so little about Pluto right now that we'll be even surprised by the things that we can settle when we see the data later on this year.
Okay, great. Any chance there's life on Pluto?
Well, that's almost a philosophical question. I would say that there isn't much chance that there would be life as we know it on Pluto, and one should not hold out. One shouldn't promise we'll find life on Pluto. That would be naive. But of course, we don't know really what the whole dynamic range of life may be in the universe, and we shouldn't be so presumptuous that we can say, well, certainly location X doesn't have life. We will have to go there and see if that's the case. I would be really surprised if we see any evidence for life on Pluto, but we don't know enough right now to say absolutely not. There's no chance that there's life on Pluto.
Great. Always a scientist, we can never say there is an absolute yes or no, right? That's a good point.
Yeah, it's again the Pluto life thing. That was not a major driver to send the spacecraft to Pluto, was to see if there was life there. Although, as I did say at the beginning of our conversation, Pluto and the other Kuiper belt members of the Kuiper belt are a deep freeze of the materials which went to make up this planet. So we do learn about where the stuff came from that eventually became life on Earth came from, and what its original composition was, and things of that nature.
Well, thank you. I have a question here for both of you to answer, or Carrie, I don't know, either one of you can take it, or both of you. Are you aware of resources for educators or anybody who wants to view and process the data that comes from New Horizons? So we're looking for a site that might be open to everyone.
Carrie, you want to answer that? I think the answer is just go to the APL site, and as the LORI images become available, anybody can download them and anybody can do what they want with them. The American taxpayer paid for the mission. They are welcome to look at the images as we do and do with them as they wish. Yeah,
that's true. They'll all be freely available. They're not necessarily released as they come down. Some will be released to the public. All of the data is not released all at once as it comes down. It will be released in batches, and then it's stored on the NASA, what's that data catalog?
The PDS, the Planetary Data System?
Yeah.
Well, I believe that public.
PBS.
Yeah, I think the public needs to check, and I may be totally wrong, so forgive me if I misspeak. I think there is a plan to show a public release version without commentary of images probably within an image within a day that it arrives on the Earth. I mean, I think the delay there is only the time it takes to process the image and post it, but we won't necessarily have press conferences or anything. The images will come down and they'll be made available to the public in a public browse format. I think that's the plan is, and again, the APL site, the Johns Hopkins University APL site, is the place to go look and see what's going to happen there. But I think that's the case, that that people can see pretty much just raw images as soon after we see them.
And then for teachers, I think a lot of teachers I've encountered use to process the images themselves, like if they want to try and glean some data from it, like the diameter of a crater, for example, or something like that, is JMARS is a really good package for image processing that has a fairly simple interface that students can grasp pretty easily.
Great. Well,
and as I mentioned before, there is an enthusiastic group of people who make up the so-called unmannedspaceflight.com that the Planetary Society hosts, and it's like, you know, the home version of a game. You can play it. You can play along with the rest of the unmannedspaceflight.com crowd, who I suspect will be putting images together and speculating on what they're seeing, and which is something that students can join in on, or students can do it themselves and then see what the unmanned spaceflight people say, and then eventually when we have press conferences, you can hear what we say.
Great. Well, I also think that that's a really good sort of closing point for us here, because, like I said, moving forward, I think that we're going to continue to be having some of these hangouts around the mission as it evolves, and I think that could be a good future, an actual future hangout for educators to help them understand where they can get this data, what they can do with it, and how they can maybe bring the data into their classroom once we have some data to actually work with. So I think that's a good idea for a future hangout with New Horizons. So I want to thank everyone who joined. We had quite a lot of viewers. You were very active, and it was a great conversation. I want to thank Jeff and Carrie for their time. Jeff, I know that we didn't get to see you, but you were certainly it was a wonderful presentation. And Carrie, thank you so much for the resources you shared. Do you have any closing statements, anything you'd like to leave us with? You know, Carrie, why should educators be bringing this in and keep following it? And Jeff, you want to leave us with a final sort of big picture takeaway about this mission?
Stay tuned. We'll blow your socks off this year.
Okay, that's a good one. Carrie?
Yes, I second that. And so, you know, capitalize on that blowing of socks off. You know, I mean, that's such valuable material for the classroom to inspire students. And we'll hope to bring some more materials to you in the coming year to help you bring it into the classroom. And thanks so much for being here. Your students are very lucky to have you spending your evening learning about something new that's coming on the horizon, no pun intended, bringing that into your classroom. They're very lucky to have you.
Great. And I'll second that. So thank you for your time. We are going to continue. WGBH Education and PBS LearningMedia will continue to bring you real-time space exploration missions and connect you to educational resources as we can. And we are very happy to work with NASA tonight on this and look forward to our next Google Hangout for teachers. So thank you very much for your time, and good night.
Good night, everybody.
Carrie, it's stopping still.